Da-da-da-da. All right. Okay. Welcome back. It might have been a while depending on when these videos get posted, because what we're going to do this video is take the simple abstraction we made at the end of the last one, and we're going to take it one step further to, I think, what is this will probably be the last video in this little series, because I think we're going to get to kind of the end of the basics and hopefully tie it all together. There are going to be a couple complications that come up along the way, which might make this a little bit of a long one, but I think it'll be a good finale, which again will hopefully let you see where we can take it and get excited for graphics, because I want people to love this as much as I do. All right, so last video we've got this function called draw triangle that takes a number, which triangle are we drawing, and it kind of shifts some numbers around based on that n, and then decides how far into our buffers to draw. Remember, we've got our positions, 2 floats, offset 0, stride 20 bytes, 3 floats, offset 8, stride 20 bytes. That's 8 bytes as well. And so those kind of point up here. So when we say draw 0, 3, that says read one attribute, one attribute, one attribute. Read 3 vertices. And then, so we're drawing 3 at a time, starting at I times 3, which I is 0, which is 0, then 1 times 3, then 2 times 3, and 3 times 3. So we're drawing all these, and we're drawing 3 of them at a time. Quick refresher on this. I said last time, when you're doing your pointers, I want you to kind of picture what your buffer looks like in your head. So hopefully you've been doing that in the interim, but you do you, I guess. I can't make you picture things in your head. Anyways. Where was I going? What we want to do is we're going to take this function, and you've got 1, 2, 3, 4 things on the screen, and each one, as much as they have different colors, we'll worry about the colors later, but you can kind of notice that they've got different positions, which, if you think about it, is something that is tied to this triangle. It's something that this triangle. I'm trying to think of a fancy way to segue into it, but really what I'm getting at is that we can make each triangle a class that has a position property, and then we can put a method on that class that will draw the triangle. Hopefully that makes sense, and extra hopefully it'll make sense once I do it. So you think about it, what makes a triangle? Class triangle, boop, and we're going to abstract away all of the things that make this triangle unique, so that we can just call one little function and boom, get a triangle. So what does it take to create a triangle? Well, in our simplest case, we're just going to start by turning our function into a class. So, excuse me. So in this case, we've got we're going to take some number n, which actually I might call triangle num, like which triangle number, or even triangle ID. And then I can go this.id plus triangle ID. In JavaScript, the this dot is necessary, and you don't put, like in C# you might do private int ID or something. Obviously, you can see that doesn't work in JS. So this is that's how you do classes in JavaScript. And you can see that if I were to do if I were to make a new triangle, then VS Code would give me, so that's how you do properties. Excuse me. I hope that didn't come through the microphone. It was a bit of a burp. So, new triangle, I set the ID, and then it's also going to have this dot position. And then, I don't know, I'll start that as just a 2-dimensional 0, 0 vector. And now, how do I make triangles? Well, just like with offset, I'm going to want to initialize these triangles in init, and then draw them in draw. So I want them to be kind of global variables. But in this case, what I'm actually going to do is not use let. I'm going to use const, because arrays in JavaScript, const triangles equals an empty array. Boop. And then I'm going to tell VS Code that the type of this array will be triangle array. So that way I get my nice little IntelliSense. So const means that this name triangles cannot be redeclared. I can't do triangles equals whatever. See there, assignment to constant variable. But it does not mean that the variable is like read only. It's not actually constant. The name, the binding triangles is constant. So use const whenever you can. Use let when you have to reassign the name. So there's my JavaScript advice for you. So to make our triangles, when we initialize, we can go triangles.push. I'm going to make a new triangle with ID 1, 2, and actually with ID 0, 1, and 2, and 3. 0, 1, 2, 3. Boop. And then when I want to draw each one, instead of calling my little function, for every triangle in my triangles array, that should be a triangle, then I can call triangle.draw. And that should be all I need, except I haven't written the .draw function yet. So we'll get to that. Inside my triangle, I want to draw a function. And to draw each triangle, well, what does it do? In this case, it computes some offset and sends that to uOffset and then calls draw. In this case, I don't need to compute my offset because I already have it, right? Like triangle has its own position. So what I can do is I can call gl.uniform to fv with uOffset. And the data I'm going to pass in is this object's position. Then I can call draw arrays, exactly like I've been doing, triangles, and I'm going to draw 3 of them, but where do I start? Well, again, triangle ID is just like that n that I passed in, so I'm going to start at 0 plus 3 times n, or, this .id times 3. And there we go. There's my triangles. Only thing you'll obviously notice is that they're no longer moving, because the triangle is not computing its offset. But even though I've removed that from the draw method, I think it's actually a little bit nicer to have it now that I can do this. Triangle.position equals, and then I can, I can put cosine back in here again, or I could even do something like, I can increment just the x of the position. Like I can actually, oops, that was maybe a bit too much. That's too little. There we go. So now every frame, I'm mutating, I'm changing every triangle. I'm changing its position. And by doing that, I don't have to worry about any uniforms or anything like that. I've done it once in my class, and now all of them are moving. Hopefully that you can see how nice that is. Now I could even do something like use the triangle's ID to have some move faster. So actually this one is times 0, so maybe I can do times ID plus 1. There we go. So now again, they're all moving differently. So that's a pretty good start, but we want to kind of, this triangle class is not a very good class. If you remember your 2240, we haven't really encapsulated much. We've encapsulated the position, but each triangle still kind of depends on, it just kind of calls draw arrays, which again, if you remember, it's depending on this buffer existing in this state with these pointers set up. So what we'd like to do instead is to call new triangle and give it maybe these 6 or however many numbers that is. It's like 15 numbers, and give it these numbers, and then have it, when it gets constructed, have it create a buffer, and then set its pointers, and then when we want to draw it, it can just draw itself. So what we'll end up with instead of this, I'm going to remove my little arrows here. I am still on the camera view, right? Yes. Trying to stop myself from saying we want to erase things because I noticed caught myself doing that like 800 times. We're going to go from this setup to instead, I'm kind of erasing some of my numbers, but whatever. Instead, we're going to have this. 1, 2, 3. I'm really bad at drawing square brackets. 3 and 4. So 1, 2, 3, 4, and on the graphics card there will now be 4 buffers. We're going to call GL create buffer 4 times, once in the constructor of each triangle, and then each triangle will be responsible for setting its own buffer data. It's going to get it from passed into the constructor, so it's not really responsible for much, but you get the idea. It's going to make a buffer and keep that buffer. Additionally then, because we have 4 buffers, the triangle is also going to have to set its own vertex attributes. But that's all part of setup. So let's just take what we have already, buffer, pass data, whatever, and we'll move that from our init function and put it in the constructor, which is basically just going to turn our init function into a per triangle init function. So we're basically just going to do a bunch of little refactoring here. So all this stuff, prepare our points array to go on the GPU, all of this is stuff that does per triangle. So honestly, we'll grab that, Control X, and that's going in here. And then instead of getting points as a global thing, we'll get that passed as vertex data to the constructor. And then that'll just flatten it and send it again, exactly like we did before. And we still have, even in this buffer, we're still going to have 2 floats at offset 0 with stride 20 bytes. Because in this buffer, 2 floats, offset 0, and then 20 bytes across, and then 20 bytes across. It's just that now we're always going to call draw arrays with 0, draw 3. And then the next triangle we'll call 0, draw 3, but on its buffer. 0, draw 3 on this one's buffer. That sort of thing. So our draw arrays starter number will always be 0 now because each one has its own buffer. Doesn't have to worry about what's going where. So we're going to get some vertex data, and we're going to pass that in. Oh, I need to do that. Array of arrays. And then, yes, I haven't passed anything yet, so this is going to break for a second. And then, yeah, that should be good. In here, that should happen when I call triangle, new triangle. So why don't I make it really clear what's happening here? Console.log triangle constructor for called for triangle. I can't spell. Triangle number triangle ID. Oop, and there we go. So it crashes when it hits 0 because we have an undefined thingy. I'm going to make this a little nicer. Again, I can't spell. There we go. So called for triangle number 0. But we crashed because I never passed it a vertex data. So now what I'm going to do is take each of these and kind of steal them out of here and no longer make them global. I'm just going to, I could make them into little variables, but I may as well just kind of stick them in here, which I want in an array first. Here we go. So push into the triangles array some new triangle here, which is, as its triangle ID, it gets a 0, and it's its vertex data, it gets the same array as before, but now it's only its chunk and not every chunk. So we'll do that for all of these. And pop. And then VS Code refuses to indent things nicely on the first try. There we go. So there we go. Program is not defined. So there's another thing. Program only exists in here. So there's a couple ways I guess we could resolve this. In a more complicated example, what we could do is actually, you know what? Let's do that. Why not? If you think about it, program, right? What this program does is in our case, it's specific to triangles. It doesn't have to be, but we're going to say that it's specific to triangles. This is our triangle shader. So really, it might make sense to grab the comment too, stick that in here, and initialize the program as part of the, what's it called? It's part of the constructor. Except now it doesn't exist down here. So, that means that if we wanted to do that, then each triangle would also have to manage its own uniforms as well. That's a bit complicated. Maybe we'll leave that for another day. Really, I'm going to fix that by doing this. Program is now up here. So WebGL program. Boop, 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 boop. And then I move this back down to init. Boop, 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 boop. There we go. So a little bit of a tangent there, deciding how I wanted to solve that problem, but there we go. Aha! Interesting. So it's working again, and nothing is crashing, except I only have one triangle, which is interesting. And you notice it's the one on the bottom left, which is the one with the negative y, negative x, which would be triangle number 4, I guess triangle number 3. So that's interesting. My last triangle is showing up. I thought I abstracted everything all nice. Got each one makes its own buffer, figures out where a position goes, figures out where a color goes, and that sort of thing. And then when it wants to draw itself, it just draws. It sets its offset for however many vertices it wants to draw, and then draws from the buffer. Actually, there's the error. There's an error. I really want this. But even that, you can see something even weirder has happened. Ooh, now I have 4 of the same triangle. But you'll notice they're offset differently. So what we're getting here, it looks like, is the 4th triangle's colors for every triangle. Let's test that. If I put specific colors in here, wink. Yeah, so if I put specific colors in there, they show up here. So we're getting the 4th triangle's colors for all of our triangles. And actually, also the 4th triangle's positions. We're getting this 4 times, but correctly offset by, I guess I'm not using this function anymore, correctly offset by the triangle's ID. What's going on here? So this is kind of where, you really got to get your encapsulation, up and running. Boop, boop. If I switch back over here, if you remember way back at the beginning when I was describing the steps for drawing triangles, it went something like create buffer, bind buffer, set buffer data, set your vertex attribute pointers. And then when you called bind buffer, I kind of drew it like this. Whoop, whoop. So we make the first triangle. It creates, these don't exist yet, pretend. We make our first triangle. We call create buffer, and we get our buffer. We call buffer data, and that puts our x, y, RGBs in here. Then we call bind buffer, puts our little brackets on here, and so now calls to vertex attrib pointer will make it so that these go into that buffer. So when I call vertex attrib pointer a position, 2 floats, offset 0, stride, whatever, my arrows will go up here. So let's do that. So that puts my arrow up here. I'm not, it also does the stride thing. And then same for a color. That one goes way up here. So that's what that does. All right, sweet. We're all ready to draw triangle number 1. Now we get to the next triangle, and it calls GL create buffer and GL. Well, yeah. So it starts by saying GL create buffer, and it makes this buffer, and then it calls GL bind buffer, which doesn't break our pointers, but it does do this. So if we call draw arrays right now, when it goes to look at the vertex positions, it would draw the first triangle. However, it tells bind buffer and then it sets its data, and then the second triangle sets its vertex positions, which will make this blue arrow, instead of going from here, vertex at your pointer looks at the currently bound buffer. So it will change this arrow from pointing here to pointing there when I call that function. Same for the color. It'll now point to here. Okay, so I got my buffer, my stuff in here, but then I didn't use it and I got my stuff in here. And that'll happen again for this one and this one. So the second triangle gets created, and I need to put the second triangle gets created. Oh my goodness. And then, this one is no longer bound. And instead, it binds this one, which is not a problem for our vertex attributes. They stay pointed into this buffer. But then immediately, part of my constructor for the triangle is to, change the vertex pointers. And then, the next one, so now the arrows are pointing into this buffer here. And then the last one happens, it makes its buffer and binds it. And then, finally, my little blue arrows go, where did the blue one go? There it is. My little arrows go into here. So I hope that's clear-ish what's happening. Maybe I'm kind of rambling at this point, but now what we have is this with my stride, or sorry, my float count and my stride, and then my float count and my stride on that one too. So now what happens when I want to draw my triangles is triangle 1, which owns this buffer, or which created this buffer and then didn't really do anything with it, it sets its position uniform, which tells the vertex shader that next time you run, U offset should be this number for the whole execution of it. And then it calls draw arrays 0 to 3. But even if this fourth buffer wasn't bound right now, draw arrays 0 to 3 says follow these attribute pointers to do the multiplication here. So start at 0 and add 2 floats 0 times, and draw and read 2 floats, and then start at 0 and read skip 8 bytes and whatever, read 3 floats, draw that, and then skip and draw those and those. So draw arrays 0, 3 is all about which multiples of these pointers you want to render. Hopefully that makes sense. So what that means is basically, in order to draw 4 triangles, I have to, or we have to, set our current pointers to point to. I need both colors again. Set our current pointers to point to here, and here, and then draw the first triangle, and then set them to point to here, and draw the second triangle, and then here, and then here, and draw the third triangle. So let's do that. And we'll see if that fixes it. So now basically what that amounts to is that this step, or actually really this step, is no longer part of our initialization step. It's part of our drawing step. So I'm going to grab these 2 lines, and I'm going to put them down here. And then that means that it needs to access these variables, so I will make those class level properties. I guess technically I'll put these ones down in here too. There we go. But again, that didn't work, probably because I forgot my this and dot, this dot, and this dot. But we have the same problem. Why would that be? Well, if you remember, setting these works based on whichever buffer is bound, which means that not only do I have to set these again, I need to set them into the right buffer. So I have to keep a reference to my buffer and rebind it every frame. What that looks like is it means that my const buffer ID is now this.bufferid, and which also means that this one is this.bufferid, and then gl.bind buffer array buffer this.bufferid. And there we go. So you can see that now we kind of have a little bit more complexity in our draw loop. But we have now kind of successfully abstracted this away. Right? We had to give it some vertex data. This isn't a huge deal because normally this would be like, you'd read this from a model file or something from some 3D mesh or something like that. But you can see, hopefully, aside from, pretend this is some triangle class, this is some other file. The logic to actually draw the triangles is now quite simple. You just call .draw, and we've abstracted the hard part away to over here, which even then, not that insane. But to finish off, I think I've been going for quite a while here. That's 26 minutes. Been rambling for quite a while, but this is going to be a finale video. To finish this off, we will kind of look at the proper way to do this. So what if I told you that this entire time I've been working with this diagram system, I had a plan. You wouldn't believe it. This little box down here that holds our attributes, we can make our own little black boxes, one for each triangle. And each one of those can hold its own set of pointers. And what these little boxes is called a, drum roll please. Thank you. It's called a VAO for vertex attribute object. Object in OpenGL terms is thrown around a lot, like literally everything is called an object. But so really it's a, actually it means vertex array object. So really you can think of these as vertex arrays or arrays of vertex attributes. OpenGL's committee is not the best at naming things. Chronos is not the best at naming things. But hopefully it's immediately clear what we can do with this power of making our own things is that we can once again take the whole configuring our pointers, and we can do it in setup and put them in our own little black boxes, and then when we have to call vertex attribute pointer for the next triangle, it won't mess up this one's pointers. It'll just set its own pointers. And so what that'll look like is something like, we'll no longer have a position down here. Woo, go away, goodbye. And there's no longer all these little pointers everywhere. Instead, each triangle, when it gets created, we'll call gl.createVertexArrays. I think that's what it's called. And it'll ask for one vertex array. And it'll get its own little black box. It then, just like a buffer, will call, I'll use, green, or I'll use red. It'll call gl.bindVertexArray, which just like my little buffers, makes this, or actually, it'll call it one at a time. That is now the current vertex array. So vertex array related functions will work on this. By default, so technically this little big box, this big box down here is a vertex array object, and it's just, this is what is bound by default if you have no other VAOs bound. So I kind of said it was OpenGL at the beginning. It's actually OpenGL's default vertex array object, which actually, if you're using actual OpenGL, like modern core OpenGL, you don't get one of these. You have to make your own. So this little kind of surprise twist lesson here only works because we're using WebGL, which is based on older OpenGL. So yeah, so now when we call create vertex array, we'll get a little box, and then we'll have our, I'll have to go really small here, but a position and a color, a position, a color, a position, a color, a position, a color. When we are setting up our triangle, we'll create a buffer. So actually, maybe I'll pretend I have a fifth triangle, and we'll go through it one more time from the beginning. So setting up a triangle, we call GL create buffer. We get a buffer down here. Next, we call GL.bind buffer to make this the current target for buffer-related operations, or I should say for array buffer-related operations. And now we call buffer data, which this is the current target for buffer operations. We put our data ends up in here. So x, y, RGB, dot, 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 dot. So we fill our buffer up with data. And now we call GL dot create vertex arrays. And we pass, we create one of them. We make a vertex array, which gives us a little black box. And then I guess technically part of this we would also call use program, which kind of, I've been drawing these little curly braces. Programs also get used and become the current thing. So I would call use program, and then it knows that the current program is going to need a pause and a color, which again, technically these are actually just numbers. This is number 1 and number 2. So if you set up your vertex attribute pointers on one program and then switch to a different program, they still remain like configured, but they remain configured based on the number. So if you had one program where position was number 1 and then another where color was number 1, you could switch programs and they would just kind of, the pointers would still, you'd end up using one pointer for the, you get it. Maybe. That's kind of irrelevant. That doesn't really happen much. Not until you start worrying about multiple programs and stuff, but that comes up much later. So next, we make our vertex array. Got a little sidetracked there. And then we call bind vertex array. So now this is still the current buffer. This also becomes the current vertex array object. Now, when we call vertex attribute pointer, the way you'll see it worded in like Learn OpenGL, like on online reading, is that it stores calls to vertex attribute pointer and stuff. I've always found it makes more sense to imagine it as like a little box with it's literally holding the pointers, not storing the calls themselves. But I don't actually know how it's implemented under the hood. Maybe it is making the calls again every time. Again, I'm kind of getting sidetracked. When we call vertex attribute pointer, these pointers will come out of this little box instead. Over here with its stride and whatever, and then color will be over here with its stride and whatever. So 2 floats and then stride to here, and then this one is stride to 1 to here. So now what we can do, it's actually in good practice to kind of, because like I've been talking about encapsulation, it's good practice to sort of, when we're done, we don't want other people accidentally messing with our buffers, so we unbind them when we're done. So I'm now done setting up my fifth triangle. When I unbound the buffers and the VAO, my arrows didn't go away, but I'm still good to draw this triangle. So then when it comes time to draw triangle number 5, I'm losing all my markers. Well, what do I have to do? To draw triangle number 5, I simply, again, I don't actually ever have to worry about the buffer again. I just have to make this the current VAO. And oh look, there's my pointers. Now I can call draw arrays 0 to 3, 0 to 3, and I'll get my triangle. So I've been rambling for way too long. We'll do that, and we'll be done with this little mini series. Hope you guys like this little hour-long special. It's like a Christmas special. So first up, we want to move this back into up here. We make our buffer. Actually, I don't need it. So we make our buffer, we bind it, and we no longer need to keep this buffer ID in the whole class. We just need to keep the VAO. So I'm going to make a buffer and set the data. Then I'm going to make a VAO gl.create vertex array. Boop. There's my VAO. And then gl.bind vertex array. VAO. Now I can grab these, which goes here and here. There we go. So now we're back to where we were before. But the difference is that now we kind of, like I said, we kind of, like the online materials say, we've stored our calls here into VAOs. Like I mentioned, we're going to also do be nice, good Samaritans and unbind our buffer by binding to null, and we're going to do the same thing with vertex array, just to do that. So we will no longer have our stuff be bound and won't escape out. And so now nothing is drawn because we unbind after we set up each triangle, which means that by the time we actually start drawing, we're trying to draw out of this empty black box. We want to rebind this to be able to draw, which is as simple as just gl.bind vertex array this.vao. Ta-da! And there you have it. There is that's object-oriented graphics for you. You do a bunch of setup in the constructor, and then drawing is insanely simple once you learn about VAOs. They seem kind of intimidating at first. I mean, maybe the fact that this video is 36 minutes, maybe they are intimidating, but, or at least, not as dead simple as I would hope, but whatever. Hopefully it makes sense what I was getting at. And this is the dead simplest case. You could make a lot of optimizations here, even more like abstractions. If you wanted to have multiple, something that might come up is like an object might query for its own uniforms, or if every triangle has the same set of uniforms, then it might have static uniforms, like static uoffset position. And then when the class, I guess it has to wait for this to happen. I guess I can, we're going to break my nice little init structure down here just to make a point. If I put program back up here. Boop, boop. I don't need to use it yet. Actually, why not? I'll make this even more. I can make the program static to the triangle equals, and then offset will be gl dot get uniform form location. Nope, location from program. And it's called uOffset. And now when I want to draw the triangle will call useProgram on triangle.program, because this is static, it's not an instance property, so I use triangle. And it will call uniform2v on triangle.uOffset. That should still work. Whoop, program is not defined on line 41. Boop, 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 boop. Because it is now called triangle.program. And now line 102. Boop, 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 boop. You don't exist anymore. Ta-da! So now you can see from outside the triangle class, it's really, really abstracted. Even better, what I could do would be something like this. Let's go really extreme with this simplification and abstraction thing. Call this main.js, and then make a new file called triangle.js. And I'm kind of extending this on and on and on. Maybe I should just shut up and let you go home at this point. Triangle.js and main.js. Except it's relying on GL. You get the idea. I can do, I can have my classes in a different file, and then my main is really simple. I make a new triangle, and then I draw them. The end. The reason this is breaking is because this depends on the GL variable, which does not exist yet. I could do something like make an init method or something for this, for the triangle class. And then that takes GL as an argument. Main.js, when I want to init, I call triangle.init. There. So that looks really simple now. And because I did that work once, I can make all the new triangles I want with just calling new triangle. And if I want to reposition them, I can reposition them. And you can see how this would scale, because if I want them to do more fancy things, I just add more properties that set more uniforms. And I did get a little bit sidetracked, but I get excited by graphics, and hopefully you also get excited. I will cut it there at 41 minutes long. Little bit of a finale. Yeah, I hope you enjoyed these little videos.